So now it's time to move forward to the rules of probability. Now we will try to understand how questions are solved in GATE. So let's understand. There will be 6 rules. We will study them one by one and do their numericals. Rule number 1. What is the rule number 1? Let's write. Rule number 1 says this is the rule number 1. It says if there are any two events A and B, then their probability of their union will be equal to probability of single A plus probability of B minus probability of intersection of A and B. Rule number 2 is, here we talked about the union, now we will talk about intersection. Probability of A intersection. This is again the conditional probability. This means probability of B when A is finished. So the multiplication of probability of B when A is finished to the probability of A gives you the probability of intersection of A and B. This was rule number 2. Now let's do some numericals. This is our first question. It says there are 2 containers with one containing 4 red and 3 green balls and the other containing 3 blue and 4 green balls. Okay, let's do it step by step. So there are 2 containers. So one container with one containing 4 red and 3 green balls and the other containing 3 blue and 4 green balls. One ball is drawn at random. One ball is drawn at random from each container. From each container it has been taken out. The probability that one of the ball is red and the other is blue will be one ball is drawn from each container. First thing. The second thing is we have to find probability that we have to find the probability of one ball is red and the second is blue. Now if we understand this, it is saying that you have to find probability of, this is equal to probability of first ball is red, then second ball will be blue. Fine. So the probability of getting first ball as red, this part is from this is the first container, this is the second container. So it will be 4 number of possible ways, 4 divided by total number of possible ways or ways is 4 plus 3. So you will write 4, 5, 7. And it is saying and the second ball is multiply blue. So it will be 3, 7. So the probability of getting first ball red is 4/7 and the second ball blue is 3/7. So first the red comes and then the blue. So its probability will be 4/7 into 3/7. So this will come out to be 12/49. So this question was from GATE 2011. If 3 identical dice as the above are thrown, the probability of occurrence of values 1, 5 and 6 on the 3 dice is. So this is the probability distribution of a dice. There is any dice, and what it says is getting the first number, the probability of getting the number 1 is 1 by 4. Getting the probability of getting number 2, 3, 4 and 5 is 1 by 8, and for 6 is 1 by 4. So the probability, this is the probability distribution of a dice. So if the 3 identical, it's 3, if 3 identical dices are thrown, what is the probability of occurrence of these 3 values on the 3 dices? Alright, so how do we solve such question? This question was asked in GATE 2007. So how are we gonna solve this question? Let's see. Now, first of all, the thing that you should remember is dices are independent. They're not dependent upon each other, they're independent. Their result will, all 3 dices will having their separate results and they are independent of each other. So the probability of getting 1, 5 and 6 will be, probability of getting 1 is 1 upon 4, probability of getting 5 is 1 upon 8, probability of getting 6 is 1 upon 4. So it will come out to be 1 upon, this is the answer. This is the next question. This question was asked in GATE 2005. So there is a fair dice, it is unbiased. A fair dice, it is rolled out twice, it has been rolled out 2 times. So the probability that an odd number will follow an even number. So to find the probability that an odd number will follow an even number. So to solve this question, we need to know what's the probability of getting an odd number. There are 3 odd numbers in a dice from 1 to 6, and total available ways are 6, so it will be of 1 upon 2. Similarly, for even, it will be again 3 upon 6, it will be again 1 upon 2. Now here again, since both of these events are independent of each other, therefore probability of getting odd after even is 1 upon 2 for odd, then multiply 1 upon 2 for even. So it will come out to be 1 upon 4. This is the next question. It says an examination consisting of 2 papers, paper 1 and paper 2, there are 2 papers. The probability of failing paper 1 is 0.3. So if I say the paper 1 is like event A and paper 2 is like event B, if I say, I have assumed it. So the probability of failing in paper A is 0.3 and probability of failing in paper B is 0.2 according to the question. And given that student has failed in paper 2, the probability of failing paper 1 is this. So probability of failing in paper 1 when he has already been failed in paper 2, and this is a conditional probability, this is equal to 0.6. These things are given to us. What we have to find? We have to find probability of A intersection B. Why? Because we have to find the probability of both papers. Student failing in both papers. So it's A intersection B. So A intersection B is, according to the rule second, is because we have PA B. So you have to multiply it with PB to get PA intersection B. So probability of B is 0.2. This is 0.6. This is the answer. This question was asked in so this is the next question. It says a fair coin is tossed 10 times. So the coin is being tossed about 10 times. What is the probability that only the first two tosses will yield heads? What it is saying that probability of only first two tosses are heads. It will be probability of getting head, then again head, then for the next 8 times you will get continuous tails. This is what he is asking. Now again, each tosses are independent. Therefore the required probability will be probability of head, probability of second head, then probability of tails up to 8 times. So I can say it will be like, this can be written as 1 upon 2 raised to the power 2. It can be said as 1 upon 2 raised to the power 2 multiplied by 1 upon 2 raised to the power 8. This will be 1 upon 2 raised to the power 10. This is the answer. This is another question. It says a fair dice is tossed 2 times. The dice that is unbiased, and it is being tossed 2 times. So the probability that the second toss results in a value that is higher than the first toss. So if we are tossing 2 dices at a time, so the total cases will be 36. How? It will like 1 comma 1, then it will be 1 comma 2 till 6 comma 6. Fine. Now what are the favorable cases? Favorable cases are those cases that satisfy that x1 should be greater than x2. The x1 is the value of the first toss and the x2 is the value of second toss. So in order to know the favorable cases, we can do one thing. We can make a matrix. How? 1 comma 1 2 3. These are all the sample space where the 2 times of your dice has been tossed. So favorable case we defined is x1 is greater than x2. The x1 is the first coordinates in each elements over here in this matrix. So this diagonal elements are of equal values. So all the elements lying below this will be following this relation or logic. So it will be like this is greater than 1, so x1 is greater than x2. In all these cases this will happen. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So through this we came to know the favorable cases are 15. Right. So now we can easily find the probability, that is 15 divided by 36. We will solve it further. We will get 5 upon. This is the answer.